Hello, we are the Continuum team from University of Wrocław. In this video, we would like to show you some details about our rover.
We are a diverse group of 9 students who are brought together by the same passion, constructing things.
We debuted last year on European Rover Challenge 2015.
One of our main goals is popularization of knowledge about Mars, science and robotics.
The rover is a singular remote platform which is 120 cm long, 110 cm wide and 50 cm high, excluding the manipulator. It is built mostly of aluminium, with steel used where durability was necessary. An example of the use of steel are those blue parts which connect the wheels to the chassis. Additional materials used in the rover are polycarbon and carbon fiber. We have selected aluminium for the majority of the construction because it is durable enough, while steel is too heavy and carbon fiber is too expensive. The rover's equipment can be adjusted for the task at hand. In each of the versions, the rover's weight does not exceed 50 kilograms. We use a 4-wheel rocker bogie suspension with an electrical engine built into each of the wheels.
The rover feels at home in hard terrain. It is equipped with 4 enormously powerful BLDC engines, 4 industrial-grade motor controllers with a custom yet complex drivetrain system featuring acceleration sleep regulation, dynamic power management or electronic stability program. Our rover's power source is a 36 volts battery pack based on a Samsung cells. It is capable of 700 watts of nominal output and stores up to 350 watt-hours of energy. Using an optimal drivetrain profile, it gives us more than 8 miles of range. The rover is typically controlled by 2 operators. One is responsible for driving the rover and the other for steering the manipulator. They constantly support each other and take care about onboard systems when the other is focused on doing the task. However, as there is no practical limit of control sessions, the number of operators can be increased anytime depending on a task's complexity. One of the most important aspects that we take into account during rover's construction is safety. Every active system on board has at least one emergency procedure that stops it when any malfunction is detected. Those include communication interruptions, software crashes, data buses slowdowns and so on. The rover has 2 red buttons. Pressing any of these will result in immediate power cutoff of all active systems on board.
On board, there is a multitude of sensors. In order to keep track of the rover's position, we have equipped it with a GPS chip. Together with an inertial measurement unit and odometry, it helps us to estimate an even more precise rover's location. The rover can also serve as a mobile laboratory that is capable of measuring the atmospheric conditions and the soil's properties. It can measure atmospheric pressure, temperature, and relative humidity. It will also have to examine a soil sample. To achieve this goal, we will use a probe that is capable of measuring soil temperature, moisture, and electrical conductivity. A unique feature of the laboratory is a custom-made Geiger counter. Our manipulator has 5 degrees of freedom and a wide range of movement. We have installed multiple position sensors on the manipulator. They allow us to track its position and visualize it in real time. We have implemented inverse kinematics of the manipulator. We can select a destination point and the joints will automatically adjust themselves to reach it. Thanks to this advanced technology and extensive training, we can complete even the hardest tasks with ease.
We have 3 digital video cameras, one of which is wide angle. The wide angle camera is at the front of the rover. The second camera is on the manipulator and it provides a first-person view on the grasper. And the third one provides a bird-eye view on the whole rover. Each camera can provide 30 frames per second full HD stream, and additionally, it can make up to 5 megapixel photographs. The rover modules communicate in an internal network which is based on Ethernet. After extensive testing, we have decided to use a 900 MHz solution. It has sufficient range for the competition requirements and it performs well even in a non-line of sight situation.
Antenna at the base rotates itself to point at the rover. It uses rover's GPS coordinates.
Thanks to the onboard GPS sensor, we can reach the designated point. We will collect the samples from the place which bears evidence of past water flow or is anomalous in any other way. We will take a panoramic photograph using a wide-angle camera at the front of the rover. To reach the 5 cm deep sample, we are going to use a carbon fiber shovel. This is the moment when the mobile laboratory comes in handy. At each examined location, we will measure the radiation, the atmospheric pressure, the temperature and the relative humidity. We will also make use of our soil probe to check the properties of the deeper soil. Some of the samples will be transported to the base station for further examination. The samples will be transported in sealable containers. We will examine the samples to search for the evidence of microbial life or the evidence of the water flow. After arriving at the approximate destination, we are going to use our outstanding visuals to locate the item. With the use of inverse kinematics, we will have little difficulty in picking up the item. The rover will be equipped with a trunk to store the collected items. Thanks to our 900 MHz communication solution, we will have no trouble operating in a non-line of sight situation. We are going to attach the carabiner to the wagon using our manipulator. During our preparations for this task, we were trying to tow many different items. We have also practiced pouring water from one container to another.
At the front of the rover, we have a wide-angle camera that will help us avoid impossible or dangerous obstacles, as both of the front wheels are in field of view.
Slopes you now see are approximately 45 degrees. The rover is going down the slope of approximately 80 degrees.
The team of 10 members is split into 3 divisions: mechanical, electrical and software. We work in agile-style sprints and meet all together at least once a week for discussion about our problems and plans for future.
The following footage shows us testing the rover and training.